All right. Good evening, everyone. My name is Lee Natero, and this is the Global Math Department. I'll be your host for this evening. Tonight, we're going to hear from Kurt Salisbury on math versus mathematics, using Desmos to honor student thinking and value student input. Before we begin our session, I'd like to tell you a bit more about the Global Math Department. The Global Math Department is an organization that is run entirely by volunteers. To keep the free high-quality PD, we need webinar speakers, webinar hosts, and writers for our newsletter. Newsletter writers share about an area of math or math teaching that resonates with them, or discusses recent math blogs that help teachers reflect on their practice. If you would like to volunteer or know someone who would be great in any of these areas, please have them email us at globalmathdepartment@gmail.com or have them reach out to us on Twitter. Before I introduce our speaker, I'm going to explain a little bit about how our webinars work. Our webinars are recorded and are available about 24 hours after the meeting ends. To view the recording, you can use the same link that you used to get here tonight. The Global Math Department community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. And if the chatter gets busy, I'll be sure to catch your questions for the presenter to be addressed at the end of the presentation. Right now, I'd like you to take a moment to introduce yourself in the chat, telling us what you teach, where you teach, and what your Twitter handle is, if you have one. And yes, this session is being recorded, but go ahead right now and introduce yourself in the chat. Let us know where you are coming into the meeting today from. Bangkok, yes. We are definitely a global math department when we have people from around the world. And I recognize some familiar names in our list of attendees. All right, got people from Canada, Texas, Philippines. There we go, Massachusetts and Ohio. All over the place. South Jersey. Washington State, all over the place. Thank you, everyone, for being here, whether it's evening, afternoon, or morning. Our webinar speaker tonight is Kurt Salisbury, and he will be sharing the topic Math versus Mathematics, using Desmos to honor student thinking and value student input. As a mathematics educator and researcher, Kurt has spent his career engaging students with mathematics in innovative ways. Kurt is also passionate about providing opportunities for all students to express their individual brilliance. He holds a degree in mathematics from Texas A&M University, a master's in education from Baylor University, and a PhD in curriculum and teaching, also from Baylor University. Kurt has been a speaker at both the regional and national level, including NCTM's annual conference. His research interests include math education, technology, equity, and educational making or maker spaces. So I'm now going to turn the presentation over to Kurt.
Thanks for that introduction. That sounded so much better and so much than I could have even done for myself. Appreciate all of you like taking the time to just hang out with me and do some math, do some Desmos. Hopefully you have a little fun. Full transparency here. I am at a hotel by an airport, so we may hear a plane fly by. Who knows what's going to happen? I think math can happen anywhere, and we are going to try to prove that tonight. Appreciate all of you from all over the world. That is super exciting just to interact with educators. And I tell people in what I do, this is actually one of my favorite things, is just interact with people, do some math, have some fun. If you haven't joined, jump in. There is the chat. We are going to get started. Looks like 31 of you are here. Hop in that link. It is paused. I'll give you about 10 more seconds to jump in, and then we will kind of go into it. If you'll notice, it's up there at the very top on that sticky. You can drop it in there, but just go to student.desmos.com, drop that in. I'm amazed that I have 47 people here tonight to, just do some math and have a little fun with it. While you're doing that, a couple things. If you are new to Desmos, you've never run a Desmos activity or anything like that, the code always kind of lives up here at the very top of the screen in perpetuity. Students are never late to class. That never happens. They're never tardy. So if anytime that ever happens, the student can always see that code up here at the very top. You can always click back on it as a teacher and it'll bring it back up. But yeah, let's get into it. I'm gonna unlock a couple screens. Let's get warmed up here. Let's get our brains invigorated just a little bit. And I am gonna unpause you. This is the first thing I'm gonna do. I'm gonna open up the next two screens, but before I do, I would love to just get your perspective on a couple things. First of all, how are you doing? Like, what is going on? I would love to know where you're at. Drag my little fun pumpkin here. Hopefully we don't have too many sad pumpkins, but if we do, we can deal with it as we go through. And then I'm going to pose a question that I've been posing lately. Yeah, what do you think is more out there? More wheels, more doors? What do you think? What are your thoughts? Is this even a wheel or a door? Do you have a different way to classify it? Love to know that as well. And with that, I'm going to use the magic of Desmos. I'm going to hop you over into the next two screens there. Love to know where you're at. Love to see where you are. And then, give me a thought here. What do you know about doors, wheels, the world? What is going on out there? Let's get a little thought-provoking question going here to kind of get us started. And of course, while you're doing that as a teacher, as somebody that's facilitating Desmos, one of the things that I love about it personally is I can see everything that's going on. And so I love the fact that we are mostly in the positive Y direction, which means we are not negative. We are positive. We've got some green pumpkins over there, but no sad pumpkins. So that makes me feel good. And I appreciate all of you being here. Just finished my fall break today. Still going on NCTM high. I am too. I got to spend all last week at NCSM and NCTM, and it was great. It was great just interacting with people, talking about math. I know it's still a difficult and challenging thing to do, but it was great to just kind of, I don't know. It's something magical happens when you're around your math peeps and you just get to have some conversations about math and math teaching and math education. And it really excited me and invigorated me too. And I love the fact that I have this presentation right afterwards. When I agreed to do this way back when, did not have the foresight. I'm not going to lie to you, but let's have some fun with it. And let's see what's going on here with wheels and doors. We got to see what's going on here. Give you a minute. Take a few seconds. Let's catch some thoughts here. What do you think? Wheels, doors, not trying to sway the gallery here, but we are definitely leaning towards one camp, which is quite interesting to me. Maybe the global math community thinks about wheels more. Who knows? Interesting. Somebody's breaking it down for ratios. I wonder if we're using sample sizes here. I've got some curiosity on that. Oh, love some of these thoughts here. Somebody mentioned TikTok. If you're not talking about TikTok, you're not teaching. We will do a little bit more of that later. So many good thoughts here. Take another minute. I don't want to rush you with this. I can feel the brilliance coming through the computer screen. Hopefully I didn't sway you too much one way or the other. I see some people too have joined in with us. We're up to like 53 people, which is even more crazy to me. So here's the link just in case. It's also up there at the very top. Hop in, join us, have some fun. Even math teachers get to be late. It's okay. Just glad that you're here. Interesting thoughts here. Some great suggestions. Let's just look at it. So we feel like we're in the wheels camp. If I was doing this live in front of you, I would have some explanations here, have some thoughts, but there's some great kind of things going on here that I saw when I was looking through your responses. The first one, I love this. It depends on your definition. I can't agree with you more, but I feel like it is open, includes parts to devices. Will there be more? Lego alone. So maybe we just need to put all things in the sense of toys here. Lego alone produces massive amounts of wheels. If you could If you count a hinge as a wheel, then every door has wheels. Ooh, that is deep. Does a hinge count as a wheel or not? Do you have to turn it all the way for it to be a wheel in itself? And then, of course, yeah, love these little simple debates. I think there's something magical about encouraging conversation and discourse, even if it's not math related, to kind of set the precedent of these are the types of conversations we should be having in our math classes as we just talk about math and have real human type conversations. Yeah, I don't know. Of course, I don't know the answer to this question. I think it's really funny to think about. Yeah, does a cabinet door count? Does a drawer count? What actually counts as a wheel? What actually counts as a door? Can I do some type of sampling size to kind of predict this? Yeah, so many brilliant answers. Thank you for engaging in that. I always love to just give some type of prompt to get us into the activity, to get us thinking a little bit. Some good stuff here I saw. But let's go on ahead and let's go into our talk. Let's get into our conversation a little bit. So I posed this idea of math versus mathematics. It is not an original idea. It is actually something that I have taken from somebody that I've really enjoyed their work. And that's my friend, Mr. Seymore Papert. He had this saying, and you can actually, I found a YouTube clip of him talking about this idea of math versus mathematics. But what he used to say is like, what they teach in school, I like to call math opposed to mathematics. Mathematics is a great jewel of achievement of the human mind. Math is a lot of boring stuff you make kids do with pencils and papers and putting in numbers. And I think that's such a profound way to kind of think about what's actually happening in our schools. What type of experience are we delivering to students? What's actually going on there? And he's really kind of drawn the line here between maybe the mathematics in the real world is not filtering into our schools enough. Maybe it is. I don't know. But similar to that wheels versus doors prompt, I want to learn a little bit from you as we go through, and I want to hear a little bit more. And so I'm going to pose this question to you. And that question is simply like, how do you define mathematics? So Papert has this definition. He calls this great jewel of the human mind. When I ask you, what is mathematics? How do you define it? What would you say mathematics might be? And the other thing there, while we're on this page, this is one of the artwork contests that we have at Desmos. This is from a student-created artwork. I think it is beautiful and brilliant. There's so many great things that we see students do. But yeah, I would love to learn from you. What is your definition of mathematics? How do you define it? What would you call it? And of course, there is some brilliant answers already filtering in. Give you a minute. I think every time I pose this question too, I get some type of brilliance I'm not even expecting. So much good stuff here. Somebody just started off with, oh boy. Yeah, maybe it is tough to define. So much good stuff. Yeah, loved some of the things that you're saying. Definitely seeing some commonalities. There's also kind of, how do we actually define this word? How do we define mathematics? How do we define learning of mathematics? There's some, discrepancy and consensus here. And so I'm seeing some great definitions. I'm seeing some words that you're using in common. I love some of the things we've got going on here. Yeah, so much good stuff. Wow. Brilliant. I probably could write a book about some of the things in here. So many good things. Keep them coming in, but let's look at a few of these. Yeah, there's just a lot of brilliance going on here, and I could probably capture a ton of these. Love some of these, just patterns, thinking, observing, the basis for everything. Like we solved it. We've got it done. Math is just everything. It is out there. It's everything. I love that definition. Again, we see this idea of studying patterns, making conjectures, looking for underlying structures and regularity. identifying and describing relationships. So kind of that same idea. I love this one too. Mathematics is a language of the universe. I love that word language right there. We think about mathematics, it is a type of language that we have. And informal language and informal mathematics should be a part of it. We allow informal language into our everyday life. So maybe we should have some informal mathematics going on. When we explore mathematics, we learn how the world works. And again, the study of numbers, patterns, relationships. We see a lot of that. I saw that word patterns a bunch just scrolling through here. A lot of you talked about describing things and exploring things in the world around you. Love some of those. Somebody even took my door theme a little bit further. Yeah, it's the key that unlocks multiple doors as it applies to so many disciplines. So we see it play out in a lot of different settings. Love some of the definitions here. And so piggybacking on Papert, pressing just a little bit further. Yeah, so let me ask you this question. Then, is the mathematics that takes place in your classroom or school representative of your definition? And I carefully try to use mathematics and math here interchangeably, which I probably shouldn't based on what Papert says. But that definition that you just gave me, is it happening in your school? Is it happening in your classrooms? Is it happening when you work with other educators or whatever role you may be? Yes, no, sometimes. Why? Why not? Are we actually doing that? Are we just having kids plug in numbers sometimes? Of course, I love seeing your answers as they're coming in. Love some of the explanations. Every time I pose this question, I anticipate what the answer might be. Yeah, love some of these. Give you just a minute, though. Let's capture a few more thoughts here. Yeah, I think some of this is true. Some of the things that you're saying here. We definitely landed in the sometimes camp here. Sometimes as far as having, maybe there's some barriers that keep us from doing the mathematics that we want to in our classrooms, or maybe sometimes it doesn't always happen. Sometimes we have to do some other things based on what's going on, or love that some of you said yes. Some of you did say no, and some of you talked too much of mimicking instead of thinking. So many of the words that you kind of had there at the beginning was observing and discovering relationships and making sense of patterns in the world around us. And then we get to this point where we are, doing steps. And so where's this natural kind of bridge between the two? Like, how are we honoring all that brilliance that you just told me about mathematics, but also getting some of the things that actually need to happen in the classroom to be successful for students? I think it's such an interesting point of tension that Papert plays on there just a little bit, and how we kind of try to marry what we need to have happen in our schools, but also being true to what mathematics really is, and this kind of jewel of the human mind and beauty and that sort of thing. So love your answers to that. Appreciate that. I want to keep us moving. I want to make sure we have time to do all the fun stuff. You don't want to just hear me talk. We definitely want to have some time to play with some Desmos stuff as we go through. So I'm going to open the next 3 screens, and I'm going to caveat it before we get into it. I intentionally, I don't know if the best way to describe it is laid a trap. If you get frustrated, don't get mad at me. I promise I'm not trying to make you mad. I'm just continuing to press on this idea just a little bit further of math versus mathematics. What experience are we actually creating for students? And again, some of your answers here were great. Some of them are, sometimes it is not the best situation. What we have going in our classrooms is not true to the mathematics that we want to see going on. And again, I probably just need to go back and read through all these answers one more time, because there's so many good ones going on here. And it sometimes it depends on the context and the situation we have. But like I said, I'm going to throw us into those next 3 screens. I'm going to kind of pin us in there. If you get upset with me, I apologize in advance. Still playing on this idea a little bit more. But really what I want you to do is play with the next two screens. You don't necessarily have to get them right or wrong. Come in here. We've got two screens for you to mess with. Screen one here, screen two. And then on the third one, I want to know your opinion here. What do you like about those two screens? What do you don't like about those two screens? Did I make you frustrated at one point? Maybe I might. Maybe it's intentional. Who knows there? But yeah, what do you think about these two screens? What's going on with it? What is your opinion or your impression of what's going on there? Love to see it. Man, and some of you are already done with the two screens. You're like, I looked at them. I see what's going on. I'm already ready to jump in and give some answers. Yeah, do that too. You don't have to get them right or wrong. Play with them. Try plugging in some stuff. See what happens. Yeah, take just a minute as we continue to press on this idea, math versus mathematics. And then we'll talk a little bit more about honoring students as well as we kind of go through. Oh yeah, seeing some of the things you got going on here, probably making a few of you frustrated. I apologize. Trying to drive home a point here a little bit. And then, yeah, if you get frustrated with the first one, move to the second one. Totally up to you there. Whatever you want to do going on. Yeah, some good stuff going on here. So take a minute, have some fun with it. Try not to display too many answers here, but dig in and see what's going on. And then love your impression, love your thoughts there on the final one. Give you another few minutes, play with those two screens, see what's going on, throw in some answers, see what's happening. Yeah, and then like I said, you don't necessarily have to get it right or wrong, but I love to know your impression, love to know your opinion, love to capture some of your thoughts on what you think about those two screens as we go through there. And I will tell you that I did this very same screen at NCTM, definitely made a couple teachers mad. So if I make you mad, I apologize. Just really trying to have a little fun with this point that I'm trying to make here. And apparently I haven't made anybody too mad because nobody's dropped out yet. So some of you are still with me here. So appreciate that. Appreciate you playing along, having some fun with it. Yeah, and see what's going on here. Then, of course, I would love to learn from you. What do you love about them? What do you think's going on here? What stood out to you? And I will caveat, those two are not official Desmos screens. They're just ones that I put together. So if something breaks or something falls apart along the way, know that it was tinkered and handcrafted by me and not one of our amazing graph team members at Desmos. All right, folks, let's go ahead and let's dive into a couple of them. Let's talk about it. I'm sure you've unraveled something that's not feeling quite right, that may mess with your math teacher efficacy just a little bit or make you not feel the warmest here. But the first screen, we have this quadratic, we have this parabola going on. Simple question, pose it. What is the equation of the graph? And I don't know, you might have entered something like this. I saw several of you enter it another way. Yeah, Yeah, and depending on what you enter, you may get a try again, even though you may feel that that's right. It is a little bit of a trap that I threw in there. Maybe if I plug it in a certain form in a certain way, I might get it to give me a positive answer, really trying to force you into one way of coming up with an answer on that screen. This one has some different stuff going on. If you got to it and tried it out, um, yeah, maybe there's a little bit more here going on. Um, maybe it's got a little bit different feeling here for you as you kind of approached it here. And we can get something close to what is actually happening going on. Or, we have the sketch ability, we have the ability to write and interpret. And I think some of you kind of hit on that point as we got to this one. Um, just the type of feedback the students were given, what feedback is actually more helpful, and thinking about like, were you really honored as a student or not when you entered those equations? How was that actually happened? Were your thoughts actually played out on the screen, or were you told right or wrong? And it's the same type of context that we had there, but a lot of it could be the way that it's presented, whether we are having students kind of just do math or mathematics. It may be the way that we approach the concept and what's going on there. And I love some of the things that you gave here. So the second screen gave feedbacks that allowed me to make adjustments. Remember back to our definitions of math that we discovered, relationships. You want to develop relationships. We need to kind of ebb and flow and figure out how those relationships are working. I love whoever put this. The first one would turn off learning. Yeah, that's the last thing we want to do for students at turn off learning. We want them to go in and think and tinker and play with things and discover some of those beautiful words that you use to describe mathematics early on. The second screen's feedback was more helpful. It really is. I love this. Yeah. It took me not very long to put together that second screen. It was just, hey, let's put in a picture. Let's really just give students multiple ways to approach it. Maybe they want to tell me a story about that quadratic. Maybe they want to sketch something about it. Or maybe they just want to enter the equation. I love honoring the way that the student interacts and drives in the input there with it. So I think I've kind of labored this point pretty far and pretty along pretty well. I'm gonna labor it one more. I'm gonna take it another step here. One of the things that I will sometimes do is just look and see, like, are there, for free time, like maybe Google some bad math worksheets and see what happens. I found this online. I hope nobody's giving this one out, but maybe they are. But let's do a little bit of it here. Let's have a little adventure here. Okay, so 0 times 0, I think that is 0. I think 1 times 0 here is 0. 2 times 0 here is 0. 3 times 0 here is 0. 4 times 0. Oh, wait, let's look at the next line. Oh, we're going to switch the order. So 1 times 0. Now we got 0 times 1. And you know what? It is also 0. Don't spend too much time doing that. Again, being really tongue-in-cheek. But think about the types of experiences that we have with students. Do they get to do math? Are they doing mathematics? Are they just plugging things in and getting right and wrong, or doing something over and over again that may not have any meaning? Here's another beautiful artwork that's done by one of our art contests. I have to put this one on here because the student is from Texas, which is where I'm from. Little bias on this one. But yeah, just thinking about those two experiences that we have in our classroom, I think is such an important thing to do. One more thing that I want to talk about here that I want to add on to it is we're obviously using technology to do this. And I know I have not moved you forward in the screen, so don't yell at me yet. But it's also an important thing that we think about the types of messaging that we have with technology. You saw that in the two screens that I had you play out. Technology can send really good messages or could send really bad messages. The other thing too is, we can be a great helpful tool. I love this idea that technology can even allow students to have better conceptual understanding and visualization of what's going on. And it can honor the way that they do things and interact with things to help support their thinking of mathematics. Like I said from the outset, I get to talk to a lot of math educators throughout the world about mathematics. I hear a lot about screen fatigue. That's something that's come up. And I don't know a better way to describe like kind of some of the pullback from technology. I think Really, this great educational philosopher, Justin Timberlake, signaled it the best. I'm tired of using technology. I just need you right in front of me. I think that's how many teachers are feeling as they've gone through the last couple of years. They want their students in front of them, but it's important to remember that technology can create those experiences as well. If it's done well, if it's done right, it can be super meaningful and super helpful for students. And so one last question before we jump in and we play a little bit more here. I'm going to move you forward. And so when we think about, when we start to think about doing this shift from math to mathematics and really honoring students and their input and their thinking, want to learn from you. What are some things that you're currently doing? Like how do you do this in your classroom? What are you doing to kind of make this shift? Maybe we can learn from each other here. There's certain ways that you develop this shared understanding of patterns and relationships and nature and understanding the world, everything that you described from the outset. Love to learn from you on the screen. And then I'm going to give a few more suggestions here about how it could possibly be done. And then we're going to jump in and play with some Desmos. I know you're probably tired of listening to me talk this whole time. And so we'll play with a few Desmos screens here, kind of with the second part, let you experience something that's unreleased, brand new Desmos stuff as you go in. And then we'll kind of bring it to an end here as we kind of enter in the second half of this presentation. So what are you currently doing? Maybe I'm not thinking about something. Let me learn from you. Is there something you're doing in your classroom that really honors students' thinking, makes that shift from math to mathematics so they're doing the beautiful stuff that we talked about, not just plugging in numbers? What are we actually going through here? Oh, so much good stuff here. So many good things going on. Yeah, so much brilliant stuff. Love what's going on. So we've got letting students talk about math, think, pair, share, for students to feel safe sharing in the class, working on the board in groups. I love group work. There's nothing better than getting students talking about mathematics. Yeah, giving them time to think. Students need time to just process what's going on. Late thinking, early thinking, mid thinking, all types of thinking is good thinking. We want students just engaging with different ideas. Some more stand and talk from Sarah there. Student work in groups. Again, this idea of groups. Yeah, and just sharing what's actually happening. We talked this idea about patterns and relationships. We should be having that same thing happening for our students, relationships going through the classroom with conversation. Love the shout out to Desmos starter screen here. More collaboration, more talking, some vertical whiteboard problems. Love that. Yeah, which one doesn't belong? That's a great strategy to use. Yeah, I love this. Just shifting the way we ask questions. Purposeful questions is such an important part of what happens in the math classroom. Somebody put in here, shifting away from any questions to, did anyone figure out in a different way? Sharing just different thoughts and different thinking. Love that. So many good things here. Yeah, love the idea of just calling math puzzles. Somebody has that down there at the very idea. Yeah, sometimes, math doesn't always have the best connotation, but thinking about it again and those words that we use to describe mathematics is so powerful. Some things that I like to think about, and somebody put in here math play and letting students play with mathematics. I think you were predicting the future here. Some of the things that I like to think about in particular, when I look at something and I encounter something, how do I really want to try to honor student thinking? How do I want to make this shift away from math to mathematics? One of the first things I really want to try to strive to do is, just bring in some real world connections. So many of you described that math describes the world around us. Probably should be bringing in some real world thinking and connections in our classroom. And it really helps support student productive disposition. We want them to see the purpose in mathematics, the why behind it, what is going on with it. Love thinking about real world connections. Somebody talked about mathematical language from the outset. Yeah, so I love just multiple representations. We should have visual. We should have mathematical language. We should present kind of the gamut of the way mathematics should be encountered for students. So many good things there. Somebody said math play. I love letting students play with things mathematically. In particular, if you are with middle school, even high school students, there's times they just need to play, encounter something, play with it, tinker with it. I can't tell you how many times I've played with something, it didn't work out right, but I learned so much from just doing that. It really helps develop this idea of problem solving. Such a great way. And then I love letting students be creators. They have so many brilliant things. When you let students create things and you step out of the way, seems like magic happens, and often they learn something along the way. So just a few things to think about as you're trying to make this shift in your classroom and what's actually happening and how you're honoring and valuing students. Such a great way to do that. And let's do some examples from Desmos. So I've talked way too much. Let's play a little bit more. Let's have a little bit fun. Yeah, so let's tackle this first one. Real world connections. I pulled a few screens from some of our Desmos activities here. And I'll just be honest with you. I'm going to open up the next 3 screens. I'm going to let you play with it. And if you are teaching right now and you are not talking about TikTok, are you really teaching? That is a fundamental question here that I have for you. If you aren't, I suggest you should be. You should be talking about TikTok. You should be talking about memes in your classroom. There's so much mathematics involved with it. The developers at Desmos Classroom made some brilliant and beautiful stuff. I love the little pictures here alongside it, and also the connection between the graph here. Such a beautiful real world understanding of when something goes viral, there's something mathematically happening behind something going viral. So play with that one. See if you can match up the equations here. See if you can connect it. And then also think about just how, these things change over time. How do actually different social media platforms change over time? There's mathematics happening behind it as well. So give you a moment, experience those 3 screens, play with it for just a second, have some fun with it. Like I said, if you're not talking about memes and TikTok, you may not be really connecting with your students all along the way. So just something fun here to bring into the classroom. And on this first screen here, you can kind of drag the animals to match them to the graph. I love the dog with the ice cream cone. I think that would probably be the one that would go most viral out of these. I don't know, maybe the duck with a hat. That looks pretty fun too. So many good things here. Love, of course, a good cat video. You can't turn down a good cat video. But take just a moment more, play with these few screens, and then I'm going to move us forward and we'll play with a couple more here. Of course, I'd love to see some of your responses as you're going through. Oh, yeah, some good stuff. Some great ways to describe what's happening here. Yeah, talking about the y-intercepts. How did the meme start out? What's going on with it? And of course, I made the joke there about TikTok and memes. Of course, there's so many different ways to bring in real world representations into your classroom. I think so many educators do strive to do that, but it's such an important thing if we want them to view mathematics, if we want them to think about math out in the world. We should need to find examples and bring them in and let them explore, let them discover what's happening, see what's going on behind the scenes there, and have a little fun with math along the way as we go through. So a little fun with that. I'm going to open up one more if you haven't gotten to it here. One last one as you're working through. Give you just another second before you move to another one. Again, you can see how we take it from that visual representation and the real world setting, and then we start layering that mathematics behind it, and you can kind of drag and connect these to the one that you think it actually is. And I love seeing some of the ways that you explain what's going on. Some of the different words that you use. It's so funny that when we present problems with educators, they always use different ways to describe it. Some of you use exponential and linear. Some of you just put it in other terms of where it starts, what's happening, how fast it's moving. Yeah, so many good stuff. Now, I am about to move us forward. You can kind of wrap up what you're doing here. I will open as we finish. I'll open this activity back up. If you want to come back and play with any of these, feel free to absolutely do so. Hoping you're having a little fun with it. And so now let's go ahead. I'm going to be that mean teacher and I am going to move you forward. Looks like you are having so much good fun, but I want to make sure we have time to get to everything. There's so many good things planned in here. So the next one that I brought up is this idea of visual and mathematical language. We should have multiple representations of content and also kind of connect and weave them to help students understand concepts. And so I'm going to open up another one of my new favorite activities that our team here has developed. So much goodness. And I'm going to first just put you in this warm-up screen here. You're going to meet our friend Shelly. And with Shelly, you're going to try to help Shelly cross over to the other side. And to do so, you're going to click on these little blocks down here at the very bottom and see if you can help Shelly get across as it to the other side, to the leaf there. And of course, I can see in real time what's going on, what you're doing, what's happening behind the scenes here. Love some of the responses I'm getting, but give you a minute. See if you can help Shelly go across here. Take just another minute. Love some of the things that I'm seeing as you're playing through. Yeah, and love some of the responses that I got here. Some really good stuff. We've got this first one that's red, purple, red, purple, red, purple. Definitely some pattern going on. We got the all red, a little bit of purple camp going on. We've got all purple, a little bit of red camp going on. I don't know what's going on with this person. They have purple randomly in their stack, but you know what? It works. You do you, how you kind of come in and approach this problem. Love the interaction there. And remember, we're thinking about visual language, mathematical language. Now I'm going to move you forward in the next one and see kind of how the language starts changing. What happens? How is this next screen a little bit differently as you go through? How is the mathematics might be represented a little bit differently here? Are you interacting with the mathematical language in a new way that maybe you didn't do it on the last screen? So give you a second, play with this one, see what's going on here. Think about how the language changes just slightly as we move to the next one. And some of you are still clicking along and playing with Shelly on that first screen, and that's okay too. But take a moment when you get there, kind of get to the next one, see how the math language starts to change. And once you've done that, for time's sake, I'm going to go ahead and open the next two. And I want you to think about how the language changes again. How does it shift in screen 22? How does it shift there in screen 23? What's different about it? What starts happening as you kind of keep going along this journey of just representation, math language, the different ways students are encountering this situation that they have going on? We'll give you just a few more minutes. So if you haven't got a chance, don't feel like you have to get screen 21 correct. Just see what type of interaction is going on there and then move forward to the next two as you go through. All right. Love this progression. Love these screens together. I'm gonna go ahead and just start talking through with them. If you're still playing with them, go ahead. I don't want to shut off anything you've got going on. But I love this idea that we start this activity, we start this series of screens with just those blocks that you played with. Students enter in, they play with a pattern, they see a block, they help Shelly try to get across. And then on the next screen, what happens? We kind of remove the blocks, and then we drop in a table there. So it's represented in a different way, a new type of language. Whether you realize it or not, a table is a type of mathematical language. It is a type of way information is filtered to students. And so I can't remember the exact answers here. So I'm going to plug in ones that feel good, and we'll see what we've got here. I'm going to get some good visual feedback. And I actually did pretty good there. Just missed the first one. But now we have this table, and it's connecting kind of that visual representation to this new language that we have in the table. And then I'll tell you, when the first time I saw this next screen on screen 22, I was like, okay, I get it. We played with a pattern. Now we did a table. Now we have a table of the graph. I'm assuming that I graph this. It's just going to go through. So I'm going to put in some numbers here. And then the first time I saw this, I was like, that is really slick. We didn't just give you the language in the terms of the graph. I love how it's actually plugged into the expression itself, and it shows how those languages are connected. So we have a table connected with the expression to the actual graph here. I think that's so slick and such a brilliant way to take that mathematical language and that representation a step further. And then finally here on this last one, now we write the expression from it, 18 minus 2x. And now we use even more algebraic language here on this third one. And just over a series of 4 screens, I went through stacking blocks to writing out an equation here or an expression here that transforms into a graph. And I love just how important to think about. It's not just that one screen in the moment or that one problem in the moment. It's the progression of language that students encounter when they think about mathematics. It's almost kind of what we do with students. We start with patterns and blocks when they're young. We start building them up, and we start adding more different ways mathematics is represented. Love just that progression of that 4 screens. Somebody said, is this activity available for public use? It is actually a try it free activity right now that you can access at teacher.desmos.com. We'll talk a little bit of that at the very end. A couple more here. I want to make sure we have time here. I may be running a little bit low. Kind of the next one I had there, I moved you forward. I was that mean teacher. But let's play a little bit. I love letting students play. If you haven't done this yet, if you have not made some parabola art, I suggest you do. Jump in here, play with some parabolas, create me some artwork. Just play with math a little bit. Have some fun with it. See what's going on here. What type of experience you have when you actually dive in and play and make some artwork here. And I can see you already hard at work. And also think about, as you're playing, what type of experience are you having with that quadratic there? What type of experience are you having as a student? When I move this, what is it changing about the quadratic? When I move one of these, what is actually changing about it? It's important to think, too, for students as they play, they discover some of the inner workings of this pattern or this representation of quadratics. And then, of course, you move it, you capture it, you move it again and capture it. Maybe you want to change some colors. Maybe you want to make it concave up instead of concave down. Kind of play with it here. But I love just understanding how a quadratic works through play. I think it's such a brilliant way, and it's fun. Making parabola art is fun. And some of you are brilliant. So many good things right here. Love how I'm honoring the type of artwork you can make. Some of this just blows my mind. Some of these are so awesome. And I promise you, you give students this cue to make some art and math, they will go wild with it. Some of these are just so good. There's so many good things happening here. When we just step back sometimes and let students play with a concept, let them play with an idea, they'll discover things along the way. Give you one more minute to make your parabola art. Again, I'm going to open this back up. So if you want to come back and finish your masterpiece, feel free to do so after we finish here. but give you one more minute here to kind of finish up. I want to make sure we have time to tackle the last thing here. I had teased it a little bit. I'm going to move us forward. I love letting students create and be creators of things. And it doesn't have to be big, grandiose things, but when we let them take control of things, we really support their mathematical identity. It really supports what they think about mathematics. And so this is from an unreleased Desmos activity. It's fresh. It's about to be released out into the wild. We haven't done it yet, but I'm going to set up the first screen here. We have a puzzle pattern. We see some suns and stars and hearts here. And the goal is to figure out the values of these. And so I'm going to do that. I think this heart is 6 because 6 plus 3 plus 3 would give me 12. Now I have to figure out the value of the sun. I'm thinking something along the lines of, let's see, 31 minus, that's 28, maybe 14 here. And then, of course, I'm going to get some good visual feedback while I'm there. But I really did this screen to set up the next screen on screen 28, just showing you how this works. So screen 28 is a challenge creator. It is a class gallery screen. It's where we turn over the control of the types of problems students want to encounter and let them create their own. I love challenge creators. I love letting students take ownership of the learning here. So in this one, you get to make your own kind of puzzle pattern that's really representative of like a system of equations. And so here you can select your shapes. You can make it as big or as little as you want to, really honoring your input, valuing you as a student with what you create and what you make. I'm doing this live, so I'm going to, you know what? I'm going to give it another one. Yeah, let's do this. I'm going to throw in some shapes here, throw in a couple suns and a house, throw in a couple more houses, and I don't know, maybe, I'm going to keep it simple, maybe a sun here too. Got my shapes. Now I've got to figure out what's going on here. Can I do it? So let's see here. Maybe, I don't know. Is it, I don't know, -3 and 6? I don't know. Let's find out what we got going on. Nope, not right there. You know what? I'm going to go back and adjust it. Maybe I challenged myself a little too much here. I'm going to make it a little bit simpler. Let's go forward. So 0 and -9. There we go. Once I get my puzzle fixed, of course, I can go back and make it much more complicated, but for time's sake, we'll make it a little bit simpler there. And then once I've done, I submit my challenge. Now I have created a problem for the rest of the class to work. And so now there are 50 of you. So 21 of you are actually on that challenge creator screen, 22. So if you can go and make your own challenge, the rest of you can actually try and solve your own question, your own problem here. In fact, I'll jump us over there so some of you can hop in and make your own. And so from a teacher perspective, I can see a bunch of you have started your challenge. A lot of you are playing with it here. Some of you are going through it. So give you a minute, create your challenge. And then, we've got one in already. Once a student has made their own, has created their own, you can actually go in and solve that student's question or solve that challenge. And so looks like we've got 57. There's 3 of them. Divide that out. So I'm thinking 19 maybe. That is the drop there. And then we've got some other stuff going on here. So let's see. Let's figure out our star here. Maybe 0 for the star there. Made a much better problem than I did. And so maybe 10 for the flower. And then what are we missing here? Maybe 2. And let's see if we got it. Where did I mess up? 20, not 40. Been a long day there. And that's going to adjust and change everything off. So you can see what happens once somebody has created one. You can jump back in there. You can go and solve it, and you can go and figure it out. And so what am I missing here? This 2, that is not right. It needs to be a negative value. So maybe -9 here. -7. 9 minus. Got it. I mastered it, got that challenge created. I can submit my response, and I can see several others of you have gone in and tried it as well. Oh, it looks like we've got a lot more problems popping up. Love the way that we just really honor where a student is at. They can make it really complicated. They can make it really simple wherever they are in their process of understanding this mathematics concept. Just another way students are honored. Love the differentiation. Love how all students can approach this. You can saw how simple I made mine because I was doing this live. Didn't want to have to think too hard about it, but some of you have made some brilliant ones already. So much good stuff there. And I am almost out of time. We've got like 5 minutes left. So what I'm going to do is I'm just going to open up the rest of it. Love to know your thoughts. If there's anything, if you have any feedback for me, if you enjoyed it, if you didn't enjoy it, always wanting to grow myself and talking. If there's questions that you have, feel free to drop them in the chat, or you can drop them in the screen as well. Just a little bit about me. And if you want to see some of these activities and want to have access to Shelly and some of the other ones, feel free to drop in there. The other thing I will go ahead and mention, Challenge Creator, if you don't know, is now a free tool for people to make their own. We just released it this week, so you can actually go and make your own challenge creator that you want to use with your students. It's a brand new feature that our Desmos classroom team just released. So if you're always like, oh, I love these challenge creators, I want to make my own, you have the opportunity to do so. It's out there. It's free for you to go in and use. So with that, with our last 4 minutes, happy to answer any questions. The other thing that I'm going to do is open up the rest of the activity. I will stop pacing you. I want to make sure that you'll have an opportunity to go back and play with anything that you want. But happy to answer any last questions that we have here, or, you know, if you need to head off to wherever you need to head off to, feel free to do so as well. But super thankful for you spending the time with me. It was really me just rambling about math education and showing you some cool things that my colleagues at Desmos made. I hope you had some fun with it. I hope it was a little break from what you've been doing. Yeah, and happy to answer any questions as you kind of go through. Feel free to drop them in the chat. Feel free to drop them here. So somebody asked me about Desmos curriculum and the TEKS. I've actually been working on that. So would love to connect. Feel free to connect with me, reach out to me. I can tell you about some of the work that we are currently doing in Texas. We have some more things planned for Texas as well. We've been doing a few things alongside the TEKS and actually aligning some of the lessons to the TEKS as well. Any other questions? Happy to answer them for you as we wrap up here, and we are in this last minute.
Yeah. That was great, Kurt. I did see a couple questions that people had asked in the chat. Somebody asked about the Shelly the Snail activity, so I grabbed the link for that and put that in the chat because, as you said, that's like on free preview right now at Desmos. And then somebody was asking about like other types of trainings related to using and creating activities, and so I put a link in there to help.desmos.com because there are some recorded webinars there that people might find helpful.
Yeah, and there's a lot more webinars that we will continue to offer throughout. I would just keep going back to the site and see that as they're coming up, they're posted a course. If you haven't followed Desmos Classroom on Twitter, it's the new Twitter handle at Desmos Classroom. Offerings will be posted there as well. I'm assuming a lot of you found out about this on Twitter, and so those will be there too. So jump in and kind of follow along. We'll be sure to be posting things. There's a lot of other things going on, like Marble Slide Mondays. I think there's going to maybe be some free activity Fridays coming up too. So again, follow along that. And yeah, I appreciate you spending the evening with me, having a little fun. I was super worried something was going to crash here in the hotel room, but I guess the Hyatt has really good Wi-Fi. I don't know, but we made it through without being interrupted by Wi-Fi or internet or any other issues. So
yeah, this was great. I love to see the challenge creator. I love to see how Desmos is basically making math accessible for all students, and really meeting the students where they're at and allowing them to explore and play. So thank you very much, Kurt. We really appreciate you sharing with us tonight.
Thank you. Thanks for having me. Like I said, this is one of my favorite things to do. Let's talk about math and play with stuff and play with Desmos. And so, I enjoy getting to spend the evening or morning or afternoon, wherever you may be, with you, showing you some fun things to do.
Yep. Yeah, definitely appreciate it. And thanks to all of you who joined us this morning, this evening, this afternoon, wherever you are. We really appreciate that you took the time to be here today. Our next webinar is on October 18th, and that session is going to be getting the best from your questions strategies in math with education professor Ed Nolan. So I thank you very much for being here tonight, and hopefully I'll see you in about 2 weeks. Good night, everyone.